Hey, it's Mr. Lum again, and we're going to continue on with our chemistry vocabulary. Our next vocab word is nucleus. The nucleus is the center of an atom. It is made up of neutrons and protons, and the nucleus is positive. So here we have a diagram of an atom. Now, this part right here, this is the nucleus. The nucleus is made up of two subatomic particles. The first type is protons. Here is one proton right here. Protons are positive. The other type of subatomic particle that the nucleus is made up of is neutrons. Neutrons have no charge. Okay, so the overall charge of the nucleus is positive plus no charge, so the overall charge is positive. Now surrounding the nucleus are electrons. They are not part of the nucleus. They are surrounding it. The next vocab word is atomic number. An atomic number is how many protons are in an atom. A nice easy way to remember it is atomic number is the same as proton number. So here's a little clip of the periodic table. We have two elements right here, sodium and rubidium. What we can see about these is that the atomic numbers are these numbers at the top right here. So in other words, sodium has 11 protons. Rubidium has 37 protons. Sometimes on different periodic tables it could look something like this. Again, this would be the atomic number, or the number of protons. Okay, this positive, or this plus sign, we'll get to that later. This right here, Na, is just the symbol of the atom. Same with Rb for rubidium, and this is the name. Sodium and rubidium. These numbers down here are what we call atomic mass. We'll talk about those things later. Okay, but the important thing that we want to focus on at this point is the atomic number, which is also the same as the amount of protons. So all sodium atoms have 11 protons. All rubidium atoms have 37 protons. Now our next vocab word is mass number. The total number of subatomic particles in the nucleus. Mass number, if you came up with a formula for it, is protons plus neutrons will equal your mass number. So all the subatomic particles inside of the nucleus. Our next vocab word is isotope. An element always has the same number of protons, but it can have a different number of neutrons. An isotope is an atom with a different number of neutrons. Let's take a look right here at two different isotopes. We have one which is nitrogen 14 and another one which is called nitrogen 15. So what this means is that nitrogen, and the symbol for nitrogen is N, has a mass number that is 14, and it has an atomic number that is 7. So this is mass number and this is atomic number. So what this means is that this right here has 7 protons and its mass number is 14. So if mass number is 14 and it has 7 protons, then the amount of neutrons that it has is 7 as well. Now here's an isotope. It is nitrogen 15. It also has 7 protons, or in other words, an atomic number that is 7, but its mass number is 15. So again, 7 protons, but this time its mass number is not 14, but it's 15. So the number of neutrons is 8. Nitrogen 14 and nitrogen 15 are the same element. However, they're isotopes of each other because they have a different number of neutrons. When we write the symbol for nitrogen 14 or nitrogen 15 or any isotope, the mass number is always written at the top right here. The atomic number is always written at the bottom right here, followed by the symbol for the element. So again, this is mass number. This is atomic number. And this is the symbol for the element. Let's get some practice looking at mass numbers and different types of isotopes. So here's a table right here. We have isotope, symbol, mass number, atomic number, protons, and neutrons. So the first one that we have is beryllium 7. I've taken a piece of the periodic table and placed it below here. You can put the video on pause at this point and see if you can fill in this table with the information provided. So beryllium, the symbol for beryllium is right here, Be. The atomic number is 4, so we're going to write 4 right here. Now, the isotope says beryllium 7. That means the mass number is 7. And that is how we write our symbol. So the mass number, again, is 7. The atomic number is 4. If you remember, atomic number equals protons. So our proton number is also 4. Mass number is protons plus neutrons. So the difference between these two is 3. There are 3 neutrons in here. The second one is a little bit more difficult. It says the mass number is 67. The atomic number is 30. So on your periodic table you have to look for, here it is, 30. That is the number of protons. The element is called zinc. The mass number is 67. The symbol then is Zn, and at the bottom is the atomic number, and on the top is the mass number. The difference between the protons and the mass number is the neutrons, and that is 37 neutrons. Now our next one gives us the protons and the neutrons. The amount of protons that are present are 87. 87 protons, which is also equal to our atomic number. Now, the symbol for this is Fr, francium. The name is francium. The atomic number is 87. Here we write the mass number, but we need to figure that out. Mass number is equal to protons plus neutrons, or in other words, 87 plus 136. Again, this is neutrons, this is protons. 136 plus 87 is 223. Our mass number is 223. Okay? Please remember that sometimes this number will be the same as this number, but not always. For example, beryllium 7, this says 9.0. Zinc is 67, this is 65. These numbers, they may be related, but they are not the same. The best way to calculate mass number is by taking protons and neutrons and adding them together.